guys, at the next stop we're going to make an LED screen. And before disembarking, please make sure to subscribe. Thank you. With a brand new scene opened up, I'm going to go straight to the Geometry Nodes tab, and I'm going to close this spreadsheet here since I don't know how to use it either. And with the cube selected, I'm going to hit New, and this is going to be our LED board. Doesn't matter that it's a cube because we're just going to sever that connection and we're going to create our own geometry in here. So this is basically just like a proxy object for everything else. So first, some geometry. So Shift A, the first thing we need to add in is something that resembles a board, LED board, which is a grid. Okay, so if we connect this to our geometry here, by all appearances, it's a plane. But if you go into wireframe mode and then play with the vertices here, you can see that it's a subdivided plane. Mildly more interesting. But most importantly, it will let us place points where each of these lines are intersecting and reference other objects, i.e. an LED bulb. So that's what we're going to use. But first, it's lying flat, and LED screens, they're always on a wall. So let's rotate it with a very common node, Shift A, Geometry, Transform. Okay, so this is for like simple movements, rotation, scale. You can do everything here. I'm just going to rotate this. Holding down Control, you can rotate it by 10-degree increments, like that, nice and flat. And then just to make this look more like an LED ticker board, let's set this to, I don't know, something that looks like rectangular, like something you'd see on like a train or a subway or something like that. And then let's just tweak this. All right, cool, looking nice. All right, now to reference objects on the points that are within this grid, we are going to hit Shift A, instances on points or 2 points. You could, potato, potato, who knows what it is. I really think they need to clear up the names on that. I always click on the wrong one. I go, oh, what is this? No, it's the first one. Okay, instances on points is the important one. And when you do that, everything is cleared. And that's because it's saying now you only want to see your points. We want to see the plane as well. So right after it, I'm going to add in another very common node, Join Geometry, and then take the output of my original transform, put that into there. And now I've got my grid back. Cool. All right, now anything I put into this instance here, this part, will be referenced on those little intersecting lines there, okay? Now you could actually, create like a little bulb within geometry nodes. I know you can do that, guys, but we also want to do some fancy stuff with materials and reference different objects. So it's much easier if it's its own object. So out here, I'm going to add a new object, UV sphere. And then in the properties, I want to change, I don't want it to be this high res because we're going to be referencing it like hundreds of times. So let's go 16 segments by 8. Whoops. 8. And then in your items over here as well, the dimensions, you can see it comes in at like 2 meters, like the size of an adult. We want it to look like an LED bulb. Try and keep things to a real world measurement. It's about like 5 millimeters. I don't know if that's actually correct. I think it is, but it's about that. And I do not want, anytime you see scale, if it's any value other than 1, problems are in your future. So I'm going to clear that, Control A, apply scale. And I want it to reference it because like there's 16 vertices around it, but there's only 8 going this way. So it's actually rotated in the incorrect direction. So side on, I'm just going to rotate it by 90 degrees like that, or just there. And then I'm going to apply Control A rotation as well. So now it's referencing it like front on. So that'll be nice when we see it. Okay. So with my sphere there, just as a demonstration, if I was to drag this down to my geometry nodes down here, and then I took this geometry and put this into my instance, you can see we have the appearance of like rivets on a ship, or like screws. What are they called? Those little bulges. They're like screw rivet. Anyways, doesn't matter. It's LED bulbs. Okay, great. Well done. Okay, now the hard part. How do we reference 2 different bulbs depending on text, right? That's really the hard bit. That's the bit that you all came here to see. Well, first of all, we need to create another bulb, and we need to create 2 materials for those bulbs. So first of all, with our bulb here, let's go material, and let's give it a material. So I'm going to call this LED off. And then the important value for a bulb that is turned off is the transmission. So let's actually go to the EV view over here and turn transmission all the way up to 1. And then roughness, I'm going to turn that to 0.1 so that it looks a little bit glass-like. And I need to apply shade smoothing. Okay, cool. Now let's duplicate this sphere. All right. And we'll create another material. So click the single user and then call this LED on. And then let's transmission all the way to 0 again. And then emission, you just want to turn that value all the way up and then pick your favorite color, whatever you want that to be your little text ticker. And I'll just set the emission strength to 5 or 8. I don't know. We can play with it later. Anyways, and then clicking on your plane again. By the way, you can see if you click other objects, you lose your geometry nodes down here. If you don't want that to happen, just click the pin icon, and then this view will always be here regardless of what is selected, which is good. Okay. It's still referencing just one single sphere here because that hasn't changed. So to reference both of them, we need to move these to their own separate collection and then reference the collection. So I'm going to select both of my spheres here, and then in the 3D viewport, hit M, and then say move to new collection. And let's give it a name, LED bulbs. Okay. All right. And we can actually turn that off. And now nothing's changed because it's still referencing the object. So delete that object info node and then drag in the collection node and then take the output of that and put that into the instance. And now we've got this mildly more interesting. Okay. We want it to reference each of the objects individually, but it's currently doing it as a whole. So first of all, click separate children and then reset children. And then you can see that it's currently only referencing one object. Most crucially, we're going to click pick index, which will let us in here most critically choose with an instance index where to place each object. Now, currently it's just doing it, sequentially, like in a row fashion, or I guess if you got like more on the Y, it'll like polka dot, but it's just going like on, off, on, off, on, off. If we put something into this index, we can define which parts are on and which parts are off. Okay, so the crucial node for this, a lot of crucial stuff going on, is underneath geometry, raycast. Now you'll see this scary looking node appear in a lot of really interesting node projects, geometry nodes projects. Anything where you've got like proximity based effects, one object getting closer to another, the raycast node. My understanding is that it's casting rays, similar to how a render engine works, in directions, and then when it's hitting objects, it's performing operations on it in a sort of simplified fashion. Now you can do a lot here. Truthfully, I haven't used it the only function I've used is Boolean, okay? The way Boolean will work is you put in target geometry, and then where it is hitting, where it is intersecting, it is doing something. So first, let's add in some geometry. So the object that we want the bulbs to appear as on, you could make it anything, but I think most people want to do text. Okay, so add in a text, and let's just rotate this 90 degrees, scale this down, and here we've got our text. Hurrah! Cool. Now, the only thing that really matters is that underneath geometry, we've got some extrusion. Because we're using a Boolean operation, there needs to be thickness so that bulbs can actually appear inside of it. Okay, cool. So now that we've got that, let's actually drag our text down here to the geometry nodes. And if we take our output of geometry and put this into target geometry, then this is the bit, ready? Where it says is hit, we're going to drag this into not where you'd think. You'd think that pink would go into pink, but no, it's inside instance index. Okay, now something has happened, but not what we expected. So the first thing is that it is doing something to the text, but it's basing it off of its like global position, like where it originally came into the scene at. So it's wrong. So change this to relative. And now you can see something is happening. Like it's clearly like doing something in relation to the proximity of the text, but it doesn't look right. And that's because another common problem of Blender is like the normals haven't been cleared. So basically where it's casting the normals from, we need to cast it from the point of where the grid is, where the bulbs are, right? And for whatever reason, it's not yet referencing that. So here, where it's got ray direction, we need to change this. So just drag out, and then you can create a new node. And then let's type in normal. Haha. And now with our text, by the way, you can't really see it because it's like hidden, but just quickly, just hide the text and you can see that it is working. It's just like we've got such a low res to our vertices here, but if we increase that, you should see, there you go. it's working correctly. Ta-da! Hurrah! Now, it's annoying to have to keep hiding the text. So in your object properties with the text selected, go down to viewport display and then set the display as to wire. So that means the most it'll ever appear is wire. It'll never be like full solid view or whatever. It's a crime what Blender does to text. It's all jagged and like destroyed, but it works. So, can't complain. And as a quick aside, if you find that your LEDs are inverted, it just means that the naming needs to change. It's working in alphabetical order, which can be correct, but somebody using a different language might have accidentally made it work the other way. So basically, just an easy way to do it is to make sure that the one that is off is named 0, and then the one that is on is named 1. And then if you just move the text slightly, then it will update it and it should be correct. So let's do a little demo here. Let's just turn that off. Let's, because we're using Eevee, why not use Bloom? Oh, got to go rendered mode. There we go. Got some nice bloom coming in there. Turn down the radius a bit. And if we were to move our text, you can see we've got a ticker. Da, da, da. And if you wanted to do a keyframe animation, you could place a keyframe there. And oh, I wasn't even on frame 1 for some reason. Anyways, over here, and you could play it back. Now, the problem, you'll notice, it looks fine. As long as the text is moving fast enough, it looks fine. But watch what happens as it gets slow, or if it's moving at a slow speed. As I go frame by frame, look what's happening to the text. It's like it's vibrating. It's like it's wobbly. And there's really no way, you could try different fonts, you could try, the different amounts of LEDs, but you'll always have some sort of this jaggedness going on. And that's because as it moves through, as the text moves over the LEDs, you can see here, there's only one line of LEDs that's appearing there, right? But then here, there's 2 together. And then, on something as complex as like an X, you've got like this part's going in, this part's going out, and it's all jagged. Whereas real LED boards, they move basically one LED at a time. So it'll just basically snap itself to the columns, the number of columns of LEDs. And we can do that. And I'm going to show you a trick to do it. Right after telling you that if you download some surface imperfections from Polygon, you'll be able to make your LED screens look photorealistic. Polygon is a library of textures, models, and HDRs that just work. Our internal team of artists create assets to a gold standard of realism, so you can just download and start rendering. Sign up today by clicking the link in the description. So the trick is to not do your animation with keyframes. So actually with my text there selected, let's just delete this pretend animation demo animation that I created. Instead, what we want to do is do our animation inside of the geometry nodes. So if we add in another transform node here between the text and where it goes into our raycast node, and then if I was to use my translate value here, you can see that I'm just moving that text exactly like I would if I was to just, grab the text and move it. So actually I can hide that text now. Okay. So what we can do is do a calculation to figure out how many LEDs there are and then snap it to that. Now, first of all, if we were to just add in, and don't do this, but just as an example, if we were to try and, add in a value into this translation node, you would see that it is moving it, but it's moving it on all 3 values. And that's because you can't just plug a value just into the X. It's also making it the Y and the Z. Very annoying. But you can fix this just by adding in let's just go search, combine X, Y, Z. So if we put that in there, now you can see it's purple to purple, but I have a single value for the X or the Y or whichever direction I want it to go. Okay, so the first node we need to add is a math node. So let's go utilities, math, and I'm going to set this to floor. So floor is a rounding type. Now, you've probably never used this before. I hadn't before this, to be honest. But basically, floor will round a value to the value that you specify. So if I was to put this in here and I just move this, you would see that nothing is really happening. And that's because the way this works is you would put this value here is the one that's being rounded to something, but without something to tell it what to round it to, it's just Actually, I don't even know where it's going. Maybe it's like snapping it to some other extreme value off to the sides. I actually don't know. But the way you change that, what it snaps to, is you add another math node after it and you set this to multiply. Okay, so now if I set this, you can see that it's now snapping it to 0.5 degree increments. If I was to set this to 0.1, you would see that the increments are even smaller. And if I set this to 0.01, you could see that it looks a lot better. In fact, it's almost about right. And this value here, that's the key, finding out what is the correct value for that matches this. And it's actually mathematical. It is this size, the distance that it's traveling, divided by the number of columns of LEDs that we've got. Now, I mean, if you actually wanted to, you could pull up a calculator and go 1 divided by 131, and you would get that value there. But then if you were to, later on change this or change the number of this, the density or something like that, you would have to keep doing that calculation. Very annoying. We're using geometry nodes. Geometry nodes is built for math, so we can do that calculation very simply. But rather than put it in like its own little thing and then have to adjust it to that, let's actually do 2 birds with 1 stone. And let's connect our size X to this empty input in our group input over there. And what that's doing is it's exposing that value. So now with the cube selected there, if I'm doing, anything in Blender, right, I could change now just the size of that. I mean, I'm sure you guys know this, but just for those who don't, it's exposing a value. It just makes it something that you want to reference in the future, you put as an exposed value so you can quickly change it without having to dive deep into geometry nodes. Anyways, now that I've done that, the reason I said it's 2 birds with 1 stone is that I can take that and I can use it in a calculation down here. Okay, so I want that, but I also want my vertices X. So I'm dragging that across as well. So I've now got size X and vertices X. And as I said, it's size X divided by vertices X. Okay, so I can do another math node like this, take that output and that output, and I set this to divide. So it is now dividing the top by the bottom, and I'm going to put this into that value. And now this should be pretty well perfect. As I move across, you can see that it's now snapping it to just the right amount, or I should say almost the right amount, because you'll notice that although it is pretty perfect, as I move it across, it is slightly changing it. And you can see it here actually as this T value, this T character, as it moves across, it adds this little tail onto it. And it's like, what's going on? And if you think about it, it's because although it is technically correct, it's the number of columns of LEDs. That's what the vertices X is here. This, what we're calculating here, is the number of moves, which means you don't count the first column, which means it's technically vertices X minus 1. So we can do another calculation. We can go math, drop this in here, between vertices X, drop that right there, set this to subtract minus 1, and now this is perfect. Ta-da! And that is how you animate a ticker LED board. And you can see it's not moving, it's not stuttering, there's no vibration looking on with the text. It is perfectly aligned. We can make this look even better though, and we can improve our geometry nodes here so that it's much more flexible. So first of all, the text, okay? We've got the base stupid text that comes with Blender. I should say it's a stupid text. I guess you got to make it like open source text or something, but it just looks terrible as far as text goes. So let's change the font. Actually researched what fonts are used for LED boards. It's actually really hard to find this info. You type in LED fonts and you just get fonts that look like LEDs. It's not helpful at all. But the one is that is apparently used for a lot of LED boards is Pop Warner. So I'll put the link for this in the description. And this is much more suitable for an LED board because it's not got rounded shapes in it where you won't be able to like read the text very well. It's all hard blocky shapes, and it usually fits the alignment of an LED board. The other thing you want to make sure is that your text is filling the entire top to bottom. There's usually not any sort of margin. I noticed looking at reference, maybe they're paying per pixel for the size of the board. They want to maximize readability, so just stretch it all the way top to bottom. And then type out your message in preferably all caps, whatever you want to say. And I want to say subscribe for more tutorials like this one. And then a simple ticker animation. You just drag it all the way out of frame, go to frame 1, shift left arrow, and then place a keyframe here. So I, and then go shift right arrow to be the last frame in the animation. Let's create another keyframe here. And then because Blender always creates a Bezier animation, let's go to, where is it? Graph editor. I just want to do it quickly, you know, just as a demonstration. Linear, there we go. And now if we play this back, we should see a perfect, no jittering, beautiful looking LEDs that you can even get right up close to and see the bulbs, and it just works, which is cool. But it could be even better. Believe it or not, it could be better. And what I'm talking about is that this, what's happening here, that the size value with this, like if I was to, you know, let's say I wanted it to be shorter now. Well, now I've got some bulbs overlapping and I would have to like adjust this, but then I'd also have to adjust the Y and the X, and we could do some what's called like some quality of life improvements. We could also make it so that we could animate not just on the X, but also on the Y. So you could have text popping in from the bottom. So let's improve this. And this is like, it's good to know this stuff because this is how you create a tool that you'll actually end up using as an artist when it's actually user-friendly. You don't have to try and like dig deep into nodes to understand it again. So this is like one of the most simplest things. We've got, you know, size X and vertices X. Why not just make this automatically adapt the number of vertices according to the size? And we can do that with the simplest thing ever, multiplying the top by the bottom. So if I just put this now into the X value there, now if I just set this to whatever density I want, now I can stretch this out to be as wide as it is, and it's creating pixels as needed, and I can make it as thin as it is, and it's subtracting pixels. Really, really simple. And I can do the exact same thing for the one underneath it. So, sorry, for the Y, I haven't even got it in here. So let's expose the Y, so size Y, and let's in properties and bring it up. Let's move that up. And actually I'm going to create, because we can reshare. There's no reason like we have to have just the X as density. We could make that control not just the density for the X, but also for the Y as well. So let's call this just density. Whoops, got caps lock on. Density. Okay. And then, oh, did I have it? I didn't actually have it. Okay. Oh. Okay. So I got to duplicate this, and let's go size Y multiplied by this base density value. And this is going to drive our vertices Y. And it's changed. And actually that's improved something, because before we had maybe more on the Y than we did on the others. So there might be, you know, like a misalignment. You know, it can sort of look like there's more pixels on one than the other, which I mean might be an effect if you wanted it, but most LED boards you want it to be uniform. So it's now fixed that for us, which is great. We just have to make sure that we're now using the correct density value, because we actually built this from what it was before. So we have to make sure that the X is using the new density value, which is going into there, and that should now work fine. The other thing we could do is, as I said, make it so that we could animate not just the X, but also the Y. So let's actually select all of this here, these 4 nodes, subtract, divide, floor, and let's make a group out of it. So Control G, it's made a group, and I just want to name this so that I can actually recall it in the future. So size, axes, because we could use it for X and Y, etc. And then this is density. And then I also want to expose my animation value. So let's put this here. I've now lost my keyframe for that because it's now exposed and it's overriding the value, but that's all right. And now, if I want to create the exact same system for the X, I don't have to like duplicate and do a bunch of stuff. It's just, I'm just duplicating the node group and putting this into the Z axis, and then make sure I connect. I have to do this correctly. Whoops. Let's just make this full screen. It's getting a little bit crazy to see, but I'm going to go size Y, density. Oops, hang on. No, I've done something wrong there. Make sure I'm using the density from the Y. Has to be correct, or else that's not going to work. This one is, yeah, it's using the correct one. And then I also want animation. So I can create now an animation for my X, animation X, and then here, another one underneath it. This is sort of like geeking out a bit. It's maybe overkill. But something like this then becomes flexible and you can use it very easily for something else. So I can now, look at this. I can make an animation for my x-axis. I can change the size. Oh, is this going something wrong? Nope, it's not. Okay, I thought it's just Eevee juddering along there. I can do this, and now I could change, the Y. I can make that bounce up and down, right? And this is great. Now, there is one little problem here, and it's something that only happens once you go beneath the value of 1 for the X. It doesn't quite line up anymore, and you might actually notice it more on the Y there, but you might see some stuttering. I'm actually not here for some reason. Maybe I have to go to like a lower value or like a lower density. Can't remember how it is that I see it, but you'll see it on like a couple of letters. Oh, there we go. Just on the U there. You can see that U was like 4 pixels wide, and then now it's become 3. Okay, so something's happened there, and it only happens once you go below 1. But the way to fix this is inside this node group here. Right before this subtract value, we're going to do another floor value to just take our density and round it to the nearest value. Oops, like that. So just floor. That's all you have to do. And that's now added it to both of these. So you don't have to do it twice because they're linked. And then now that problem shouldn't be there anymore. You can see that it's now got the exact same consistent width across it. And that's it. So now we've got a completely flexible system. Doesn't matter what I want to do. I could change the density for both axes very easily. I can change the scale of it, the height of it, and we can do some fun stuff. So this is the final node setup. I know it's a lot to take in, so I've put the link in the description where you can download this exact blend file so you can open it up, play around, and make your own animations. And if you really want to push it over the edge, switch to cycles and then download these 2 textures from Polygon. I'll put a link to those in the description as well, and then use this node setup and it will look really nice. And if you want to learn how to make a multicolored LED suitable for a Jumbotron, then check out this tutorial by my assistant Bill, who teaches a completely different method, but one that you might find interesting. So thanks guys, blast whatever messages you want out there with your LED boards. Look forward to seeing them, and I will see you in a future tutorial.